Welcome to statistics class. This is our lesson, probability and probability distribution. Our topic, normal distribution. Recall in our previous topic that the probability of an event is between 0 and 1. Also, the sample space could be discrete or continuous. When I say discrete, let's say head or tail or 1 or 2 or exact value. Or continuous, when I say continuous, it could be uninterrupted sequence or in a range or infinite. Example, in a range between 1 to 3, I can have a sample points 1.01, 1.001, 1.002, 1.2, 1.3, so on and so forth. So now here there are different distributions. We can have t distribution, chi distribution, but the common is normal distribution, and many distribution can be approximated to normal distributions. And of course, this normal distribution also follows the principle of probability, and this normal distribution is under the principle of probability and counting, however, in a continuous distribution. So let's define normal distribution. It is an assessment of the normality of data, is a prerequisite for many statistical tests, as normal data is an underlying assumption in parametric testing. The normal distribution is used in the analysis of data in determining parametric and non-parametric tests. Its graph is called normal curve, and the mathematical equation of the normal curve was first described in 1733 by de Moivre. And then, in our previous topic, we have learned the random experiment and its principle. Now, let's apply this also, however, in a continuous random variable x. So this normal distribution is a continuous random variable x is said to be normal random variable if it follows a normal probability distribution specified by a function f of x is equal to 1 over sigma square root of 2 pi e to the power of negative 1/2 multiplied to x minus mu over sigma quantity squared. Note that x, the value of x is from negative infinity up to the positive infinity. So this is the distribution of the normal distribution looks like, where mu is constant and the mean and x is between negative infinity to positive infinity, and also the standard normal or standard deviation is constant, where sigma is greater than 0 and the pi is 3.1416, and e is based on a natural logarithm of 2.71828. And let's learn the properties of a normal curve. Let's not compute how the normal distribution have the certain function or formula in the previous slide, but let's just see or its application. You can also see that in page 303 in our textbook. So it is a bell shape and unimodal. So if you can see in the graph or in this drawing, so it looks like a bell shape and unimodal. When you say unimodal, having one maximum point here, and then it is symmetric, so we can see here from start to 0, and then the left and the other side are equal, so they are symmetric, and it is asymptotic to the x-axis. We can say the end tails approaching to the x-axis. And again, the probability principle that we have, so the total area under a curve is 1. So it has a distribution with 68% here from one standard deviation. 68% of your observations fall within this area. So it can be that your mu or your mean minus your standard deviation, and then to the range until your mu or your mean plus your standard deviation. And 95% of the observations fall within the 2 standard deviation or in the range of mu minus 2 standard deviation until your mu plus 2 multiplied to your standard deviation. So in this area, your observations are 95% of your observations fall within this area. And then 99.7% of the observations fall within the range of mu minus your 3 multiplied to your standard deviation and mu plus 3 multiplied to your standard deviation. So in this area, this is 99%. So let's proceed to standard normal distribution. It is normal distribution with mean 0 and a variance of 1. So even standard deviation is also 1 squared, so the variance is 1. So the random variable which follows the standard normal distribution is referred to as the standard normal variate, denoted by Z. So whenever you see in your textbook Z, it signifies that it follows a standard normal distribution. Thus, we write in this mathematical form, you can read that Z approximately normal with mean 0 and a variance of 1. So since each normally distributed variable has its own mean and standard deviation, as stated earlier, the shape and location of these curves will vary. So in practical application, So in practical applications, then you would have to have a table of areas under the curve for each variable. To simplify the situations, statisticians use what is called the standard normal distribution to simplify our normal distribution as projected in our previous screen and the complexity of its computations. So let's now proceed and apply these principles. So we have learned the z-score. So standard normal curve formula is z is equal to x, that is your value, your observation, minus the sample mean over your sample standard deviation, where z is your standard score, x bar is your sample mean, and s is your sample standard deviation, and x a given value of a particular variable. So the z-table, this table summarizes the cumulative probability distribution for z. So mathematically, you can present it this way. The probability of z, this is your distribution, less than or equal to your z-score, your z-value. So this is in this area. So whenever you see this mathematical presentation, it signifies the probability under your or that falls within your z score or z value. So in this area. So let's proceed. So this is the standard normal distribution table. You can also see that in table E in our textbook. So you can call this cumulative standard deviation. So this is the table values represent the area to the left of the z-score. So the procedure in finding the area under the standard normal distribution curve, we have the three cases. So case 1, if you're looking for the areas to the left of any z value. So in other words, here in this shaded area. So if you are looking for the area to the left of this z value or your computed z-score or your computed value z value. So look up the z value in the table and use the area given. So mathematically, you can present this one. Probability of p, probability of z less than or equal to your z value. And also, for case 2, to the right of any z value. For example, if you are asked, what is the probability greater than the z value? So here to the right. So you have to understand and comprehend the question. So to the right of any z value is greater than z. So look up the z value and subtract the area from 1. Note that this whole area of the normal distribution is 1. So probability of z greater than your z value is equal to 1 minus the probability of z less than or equal to your z value. And then, in our case 3, if you are looking for the area between two z values or z scores, so look up both z values and subtract the corresponding areas. So mathematically, you can present that probability of z1, so this is the value, remember, less than or equal to z, so this is fixed, this is the distribution, less than or equal to z score or z2 value. So is equal to, so you have to look for the greater valued z score, or I mean the greater z value. So that would be first, probability of z less than or equal to z value 2 minus the probability of z less than or equal to z1. So, to note of the transformation theorem, given a normal random variable x with mean mu and variance sigma squared, so this is a Greek letter, sigma squared, then z is equal to x minus mu over sigma, or your population standard deviation. Follows the standard normal distribution. So in symbols, if x random variable uh, is normally distributed with mean mu. This is, if you see this in statistical books, it signifies mean, population mean, with a variance of sigma, then z is equal to x minus mu over standard deviation approximately follows the standard normal distribution with mean 0 and a variance of 1. And also remember the rules in computing probability. So what we have learned in our probability principles of counting and principles of probability is also applicable here in our normal distribution. So here is there is a rules in computing probability. So if the probability of z is equal to a is equal to 0, hence the probability of z less than or equal to a is also equal to probability of z less than a, since this is a continuous distribution. And the probability of z less than a, it can be obtained directly from the z table. So, and then another principles or rules rather, probability of z greater than a is equal to 1 minus probability of z less than or equal to a. So this a, you can have this z because it's a z value. So it's just a general rule. So probability of z greater than negative a value is equal to probability of z greater than a because they are symmetric. And also the probability of z less than a, negative a, is also equal to the probability of z less than a. So since they are symmetric. Moreover, the last rule is if you're looking for the value between the two values. So the probability of c between a1 and a2 is equal to probability of z less than or equal to a minus the probability of z less than or equal to a1. So let's have some few examples. So in page 306 in your textbook, so find the area to the left of z is equal to 2.06. So it's after you've computed for the z score. So step 1, draw the curve and locate the z value. So here is our location of our z value. And then since our question is find the area to the left, so we are looking for the areas in this shaded yellow area. So look for the area under the z value. So you have to use that table. So here, area under 2.06. So we have here and this side 2.0, and then point up 0.6. So our area is 0.98030. So we are looking, so in textual presentation, you can explain it this way. We're looking for the area under the standard normal distribution to the left of z is equal to 2.06. Since this is an example of the first case, look up the area in the table. So this is an instruction. It is 0.98030. So hence, 98.03% of the area is less than z is equal to 2.06. So if you have to present mathematically, just present it this way. So substitute your z value here. Remember in our previous slide, the small letter z. So probability of z less than or equal to 2.06 is equal to 0.9803. And then example 2. We have find the area to the right of z is equal to negative 1.19. So another one, another step, step 1, draw the curve and locate the z value. So it could be here. So negative 1.19. And then since the instruction is find the area to the right. So we are looking for the area in this yellow shaded area. So mathematically, we can present it this way. So probability of z greater than negative 1.19. So here is the table using our z table. We are looking for the area to the right of z is equal to negative 1.19. So this is an example of the second case since it is on the right side. So look up for the z, for the area of z less than or equal to negative 1.9. Remember the rules on computing the probabilities. So it is 0.1170. Subtract it from 1. So 1.1 minus 0.1170 is equal to 0.8830. Hence, 88.30% of the area under the standard normal distribution curve is to the left of z minus negative 1.19. So if you are asked to present your answer in a mathematical form, just present it this way. The probability of z less than minus 1.19 is equal to, remember the case 2, 1 minus the probability of z less than or equal to negative 1.19. So recall that our probability in the area of negative 1.19 is equal to 0.0117. So using the principles and rules of computing for the probability, especially in the case 2, we have 1 minus this area. So 1 minus 0.1170. So in other words, probability of z greater than negative 1.19 or the probability of z on the right side of negative 1.19 is equal to 0.8830. So it will be in this area. Recall in probability of z less than or equal to 1 point negative 1.19 rather. So let's have another example. To finding the area between the two values. Z is between 1.68 and another value, Z value is negative 1.37. So draw the curve and locate the Z value. So we have here between the negative 37 and 1.68. So we are looking for the area in this yellow shaded part of the distribution. So in mathematical form, we have to present it this way. So probability of negative, since this is a lower value compared to 1.68, so probability of negative 1.37 less than or equal to z less than or equal to 1.68, or the probability of c between negative 1.37 and 1.68. So using the same table, the z table, we look for negative 1.37. So here, negative 1.3 and then up 7. So we have the value is 0.08534. So, and then we have another 1 point, and for the and another 1.68, we have the value is 0.153352. So since the desired area is between two given z values, look up the areas corresponding to the two z values and subtract the smaller area from the larger area. Again, do not subtract the z values, but the probability. So the area for z is equal to 1.68 is this one, 0.95352, and the area for z negative 1.37 is 0.853. So the area between the two z values is 0. So this is the greater area, 0.9535 minus 0.0853 is equal to 0.8682 or 86.82%. So mathematically, we can present it this way. So if we are finding for the probability of the z value between negative 1.37 and 1.68, then we can present it this way is equal to probability of z less than or equal to 1.68 minus the probability of z less than or equal to negative 1.37. So note that the probability of z less than or equal to 1.68 is equal to 0.9535. And then the probability of z less than or equal to negative 1.37 is equal to 0.0853. So now, having these values and following the case 3 guide on finding the probabilities, we can have this, the probability of the z value between the negative 1.37 and 1.68 is equal to 0.9535 minus the 0.0853 is equal to 0.8682. So, when you must find, if you're looking for the value of x, you can also compute it by a simple transformation. So when you must find the value of x, you can use the following formula. X is equal to z value or your z-score multiplied to your standard deviation plus your mean. So like for example, this area you are given, you are looking for the value of x instead of the probability. So up next, for our module 7, we have hypothesis testing. So thank you so much and may God bless you.